Whenever we wanted to show only the columns or attributes, at that time we have to use this projection operation. Whenever we are using this union operation, at the time the domain of an attribute should be same. Whenever you wanted to fetch a particular column, then we have to use project operation. I am going to take the tables as an input. After the processing, table only will going to be produced as a output or a outcome here. Hello everybody, a warm welcome to one and all. Welcome back to the session 1 of chapter 2 in the unit 2 of B.Ca's third semester subject called Database Management System. In short, it is Dbms. I'm Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So as you all know that in the chapter 1 of this unit 2, we had a discussion regarding relational models. So in our today's session, we'll start with the second chapter, that is Relational Algebra. So then what is the agenda of our today's session? So in this session, you will be learning regarding what do you mean by relational algebra or introduction to this relational algebra. And also, you will get to know what are the basic relational operations we have. Along with that, I will be discussing what are the set theoretical operation which can be performed on the relation. Already you know that relation is nothing but that's a table that comprises of rows as well as the column. So, by making use of that relation, we are dealing or we are performing all these operations. First, we'll understand what this relational algebra is all about. So, here you can see the definition of relational algebra. It's a procedural query language. So, here also we are fetching the data. For that, we are writing a query. Then, how do we write that? It means that it tells what data to be retrieved and how to be retrieved. So, when it comes to the relational algebraic operation, there we are going to use it as a query language which we are using or which will going to let us understand how to retrieve the data and what kind of data should be retrieved. In order to deal with that, we have this relational algebra. So in this, it will going to have a set of operation that take one or two relation as an input and produces a new relation as their result. So input is also relation, the output is also going to be relation. That means we are dealing with the tables. I am going to take the tables as an input. After the processing, table only will going to be produced as a output or a outcome here, so that it works on the whole table at once. So we do not have note to use this loops. So here, whenever we are working with this relational algebra, at a time whole complete table will going to be taken as an input. So we no need to have any iterations or no need to use any of the loops concept in this relational algebra. Fine. Then what are the fundamentals operation we have in a relational algebra? So here we have several fundamental operations of relational algebra that comprises of select. You will get to know what the select, project, union, set difference, Cartesian product as well as rename. So I will be discussing each type of relational operation one by one in coming slide. As of now, you have to understand what are the different relational operation we have. We have select, project, union, set difference, Cartesian product, and also we have rename. Apart from this, these are the fundamental. So when we wanted to extend the operation, for that we have this additional to the fundamental operation. There also we have several other operations that include set intersection, natural join, and also we have assignment operation here. We'll start with the first one, that is what select operation. Here we have a select operation. So there we are going to use a sigma symbol in order to represent it. Already you know that whenever we are using this relational algebra, we are taking a relation as an input. If it is a relation, that is table. If it is a table, then we have rows and column. When you want to fetch a particular row, then we are going to use this select operation. Whenever you wanted to fetch a particular column, then we have to use project operation or a projection operation. As of now, we'll start discussing the select operation here. It selects the tuple. Tuples are nothing but rows, or it is records that satisfy a given predicate. So whatever the condition that we are giving of the particular relation, based on that condition, particular tuples will going to be written as an output here. So that here we have to use a Greek letter called sigma. that symbol will going to be used in order to perform this selection operation. So here you can see the syntax. Here we have to use the sigma and selection condition. So in the subscript we have to write the selection condition. On what condition we are selecting the particular tuple from the relation. So here R specifies the name of a table. So there we are going to use this syntax in order to perform the select operation. We'll see one example so it will be easy for you in order to understand. So here we have a loan relation. What is the name of a relation? Loan. Then how many columns do we have? We have 3 columns. One is branch name, loan number, and also we have amount. So you just imagine I wanted to fetch the rows whose branch name resides in Perry's side. Okay, that means I wanted to fetch only these 2 rows whose branch name is in Perry's side, or whose loan number is L15, or whose loan amount is 2000 rupees. So in that way, if I wanted to fetch a particular tuple based on certain condition, then we have this select operation. So as of now, let me go with this example. I wanted to fetch the branch name when it is equal to Perry, right? So here you can see that I have to use sigma symbol. What is the condition? The branch name should be Perry, right? Then what is the name of a table here? That is name of a relation, loan. So here that will going to be written as an output. I had taken the input as a relation. We had taken the relation as an input, and this is what the condition. The branch name should be Perry, right? So of the loan table, from that table the branch name where the Perry right we have, that row, particular row will going to be written as a output. So that is what you can see here. Branch name, loan number, and amount. Perry right L15,500, Perry right L16,300. This is how this select operation will going to work. Then what if I wanted to select particular column based on the condition? For that we have this projection operation here. It is used to project only a certain set of attributes of a relation. So whenever we wanted to show only the columns or attributes, at the time we have to use this projection operation. Tuples or rows with the help of selection, columns with the help of this projection operation. So here what is the syntax or what is the operator we are using? That is project operator. What we are taking as a condition here? Column. I am taking a column. We are retrieving a column of a particular relation. So use this projection symbol and mention the number of column which you wanted to take. That means column name 1, column name 2, column name up to n, and there you have to mention the table name. Okay, here you have one example. What is the table name? Customer. Then how many columns do we have? Name, street, city. So these are the 3 columns. What if I wanted to see only the name of a customer? How I am supposed to write at that time? I have to use a projection operation. Then what is the column name? That is name. Okay, and I should mention the table name, that is customer here. So whenever I am doing it, I can get the whole this name column from the customer table. Here you can see the example. What is my input? We have a projection operation. I am looking for a name as well as city. Already you know we have 3 columns here, name, street, city. Out of that I wanted to fetch only name as well as city. So only 2 columns I required excepting this street column. So here you can see name comma city of customer table. Then what will be the output? I can get the name as well as the city. Moreover, it is going to remove the duplication. Only the unique value will going to be displayed here. We'll see the next operation, that is union operation here. What if you wanted to combine the data of one table with another table? Then we have this union operation. It is used to fetch the data from 2 relation or table or by the temporary relational resultant. So here if you take the example of this union operation, what it will going to do? In order to work with this union operation, we have to follow certain condition. What is that? So the relation or a table specified should have the same number of attribute. For example, if I am taking S1 and S2 as a 2 table which I am going to use for this union operation, at the time the number of columns should be same. S1 is having 2 columns, then S2 must also have only 2 columns, not more than that. And then what is the next condition? And same attribute domain. That means what? Whenever we are using this union operation, at the time the domain of an attribute should be same. For example, if I am taking integer here, then the first column of this S2 also need to be integer. If it is a varchar, then here also it should be varchar. That means there must be a compatibility between the data types which we are using. So that is what we call a same domain attribute. Fine. These are the rules. Then whenever we are getting the output from this union operation as a single relation, at the time it will going to eliminate the duplication from the resultant. For example, if I have a same name in both the table, at the time that name will going to be comes only one time instead of twice. That is what it will going to eliminate the duplicate tuples are automatically eliminated from the resultant. That is what we can see in this union operation. You can see the example here. We have a two relation here. One is depositor relation and another one is borrow relation. In the depositor relation, we have a two column, that is customer name and account number. In the next relation, that is borrow relation, there we have a customer name and loan number. So you can see the compatibility between the two tables, correct? Here we have a customer name, that is varchar. Here also I have a customer name, that is varchar. The compatibility between the first column of both the tables are same. And we have two columns in the depositor, two columns in the borrow. That means the number of attributes are same or columns are same. And if you take the example of account number and loan number, both are varchar here. So we satisfied a condition with respect to this union operation. We'll see the example. So I am going to combine customer name of borrow. So why this symbol we are going to use? For projection operation. And that means what? I am taking only column. What column I am taking? Customer name from the borrow, and we are using this union operation or operator, and customer name from depositor. So we are taking the customer name from borrow table and also customer name from depositor table. So here you can see the output. It will going to fetch the column from both the borrow table as well as from the depositor table. So if we have any duplicacy, then that will going to be removed or eliminated automatically. So here we have a Johnson. Do we have any Johnsons here? No. Smith. We have a Smith, that will going to be comes only one time because we have a duplication in both the table. Smith comes only one times here, and also we have Smith one more time here. So by removing or by eliminating that duplication, you can get the resultant here. So you can observe we have Smith only one time. What is the next operation? That is set difference. The content which we have in one relation but not in another relation. Then we are going to use this set difference. This is used to find the data present in one relation and not present in second relation. Then what symbol we are going to use? Minus A minus B. So A is one relation, B is another relation. The content which we have in A which is not in B, in order to illustrate that we use this A minus B. And what is this B minus A? The content which I have in a relation B but not in a relation A. Then we are going to use this B minus A. You can see the example here. Projection operation customer name of borrow minus projection operation customer name of depositor. So what is the first relation? Borrow. Second relation is depositor. You can see the example. So borrow is the first relation, this depositor is the second relation. The name which I have in borrow relation but which is not present in this depositor relation, that will be the output here. Okay, here we have a Johns but Johns is not here. So here also we have a Johns. So it will come as a output. And Smith, that also we have, and Hayes, that is also not present in this. So you can expect this resultant Hayes. Let me mark like this. And also we have a Jackson but not here. We don't have Curry in this depositor table. And we have Smith, Williams. Williams is also not there in this. So we are going to get 4 values called Hayes, Jackson, Curry and Williams. So these are the name which is present in the borrow relation but not in the depositor relation. If we interchange this, that means the customer name is there in depositor table which is not there in the borrow table, then you can expect another resultant. This is regarding set difference. We'll see the next one, that is Cartesian product. So when you wanted to combine the data from two different relation into one and fetch the data from the combined relation. In order to do this Cartesian product, we are going to use this multiply symbol or into symbol. So you can see the example here. Here we have a employee and department. In the employee ID, name and employee department. What Cartesian product will going to do? This is 1 to n. That means the first row will going to be combined with all the rows of a second relation. Again, the second row will going to be combined with all the rows of a second relation. Same way, this third row will going to be combined or multiplied with all the rows of a second table. So here 3 3s are 9. Here I have a 3 rows. Here also I have a 3 rows. So it will going to get us 9 rows. But how many columns? Here we have a 3 columns. Here also we have a 2 columns. So 3 plus 2, 5 columns we will get, and also we will get 9 rows as an output. You can see the example here. Whenever we are doing this Cartesian product, that means what? Employee Cartesian product. Then what is that? Department. Whenever we are doing it, employee into department, whenever we are using this Cartesian product, all the rows of a employee will going to be combined with all the rows of department. So you can get 9 rows and 5 columns whenever we are having this Cartesian product. I hope you all understood regarding Cartesian product. Next we have a rename operation. As the name indicates, if you wanted to rename the table name, at that time we can use this rename operation. It is used to rename the output of a relation for any query operation which returns a result like select, project, etc. or to simply to rename a relation or a table name. There also you can use this rename operation. That means what? Whenever we are doing relational operation like selection, projection, at the time we are going to get the table or relation as an output. If you wanted to rename that resultant output, then you can use this rename operator. So we are going to use a symbol called row in order to specify this rename operator. Then what is the syntax here? First we have to mention the row symbol and then relation new. That means you have to specify the new relation or table name, comma relation old. Consider the example here. We have a row symbol and student 1. So it was student. Now I am changing that into student 1. The name of a relation was student. Now it is getting changed into student 1. This is how we are going to perform this rename operation. So all these are regarding what? Fundamental operations of a relational algebra. Next we can see a additional relational operation. So whenever it comes to the some common database requests which are needed in the commercial query language but which cannot be performed with a basic relational operation, at the time that has to be decided or that has to be expressed as a request. That request will going to be enhance the expressive power of the relational algebra. So whenever we are having this additional relational operation, that is going to improve the efficiency of this relational operations or relational algebra. So in that we have several additional relational operation that includes aggregate function and grouping, recursive closure operation, and also we have join concepts. So all these are considered as additional operation which is going to be used. Then here you can see the next concept, that is set theoretical operations on relation. So here we have a 4 set theoretical operation, that is union, union all, minus and intersect. I will just brief you out regarding union, union all, minus and intersect here. Moreover, first we have to understand these operators are used to get the desired result from the table data stored in the table. From the table data, we are fetching the data. So whenever we are performing this set theoretical operation, however we are going to do the set operations in the mathematics, same way here also we have certain different types of set operator, that is union, union all, minus and intersect. First, you can see the brief introduction regarding all these operators here. Union, already you got to know. What is union? It will going to combine the data from one relation with another relation. But what is the main advantage? It will going to eliminate the duplication. So you can't see any of the duplicate record or a tuple from a relation. Then what about this union all? It is also going to combine or fetch the data from one table with other table, but here it will not going to eliminate the duplication. You can see the redundancy or duplication tuple in this union all. Then what do you mean by this intersect? The data are a tuple which is common in both the relation. Then we say that as a intersect. Then what is minus? This is like except, which is there in first relation but not in second relation, which is there in second relation but not in first relation. For that we have this minus. See, union combines the distinct results of two or more select statement. Then why do we require union all? It combines all the results of two or more select statements including the duplicates. That is one more disadvantage from this union all. Then intersect, it will going to returns only the common records which is present in both the relation. Only the common content will going to be obtained from this intersect operation, and we have a minus, returns only those records which are exclusive to the first table, which is there in first table but not in the second table, that we can get from this minus operator. Here let me consider one example. Consider the table S1 and consider the table S2. So in this I am going to take two column, student ID, and also we have name. Here also I will take student ID and name. 1, 2 and name. Let me consider Raju and Shri. Here 2, 3. So these are the content which we have in table 1 called S1 and table 2 called S2. Just understand, we have a 2 columns in both the table and the domains are same. This is what the rules we have to follow. We'll see the resultant for each of the set operation one by one. First, what we have? Union. What is the syntax? We are using a select predicate here. Select expression 1, 2 up to expression n. That means based on the expression. Select name, select city, like that. Okay, from table 1. Why? Because we are dealing with 2 tables here, and then I have to use a keyword called union. After that, select expression 1, expression 2, expression n from the table 2. This is what we have to mention. So now you just imagine, I wanted to select the student ID from this S1 and S2 by making use of union. Then what and all I am going to get? 1, 2, 3 or 1, 2, 2, 3. I am going to get 1, 2, 3. Why? Because that will going to eliminates the duplication. So what will be the output? For example, select student ID from S1. Table name is what? S1. And I am using union operation. Select student ID from S2. Okay, what we are going to get as a resultant for this? I am going to get the student ID which is unique. 1, 2, 3. Okay, this is how union operation will going to perform. Then what about this union all? Same thing, but here we have to use union all. So how do I get the output for this? Select, let me take name, select name from S1, union all, select name from S2. Okay, what will be the output? What was the name that I had taken? The name will come as a column here, and it will going to include, first we have Raju and Shri. Again from the second table I have Shri again, and then Sona. Fine. This is how the union all will going to work. That means we have a duplication in the union all operation. This is regarding union all. What is the next one? We have intersect. So here we have to change only intersect. Let me take the example which will going to return the common values. Select name from S1 and intersect select name from S2. What it will going to return? It will returns the name column which is common in both the S1 and S2. There we have Shri. Fine. This is how this intersect will going to work. Then what about this minus? So in order to work with this minus, we are going to use except keyword here, which is there in table 1 but which is not there in the table 2. Let me take an example here. Select student ID from S1 except select student ID from S2. Can you guess the output for this? What we are going to get? We will get the student ID as a resultant, which is there in first S1 table but not in the S2 table. That is what student ID 1. Why? Because we have a student ID 2 in both the S1 and S2. This is how we are going to use this minus or except operation. I hope you all enjoyed my today's session and I hope you all understood as well. In my coming session, we're going to learn about the join operation, which is additional operation. And also we have aggregate function and grouping. Last topic of this chapter, that's all regarding views. That is what I will be discussing in my coming session. Wait for that. Until that, keep learning, keep on growing. Thank you.